We're going to go ahead and take a look at a couple of examples with quadratic inequalities. And this is from section 1.7. Specifically, we'll be looking at numbers 53 and 55. So for 53, we're going to start off with the following quadratic: x squared plus 7x plus 12 is less than 0. So with the problem, what I want you to note is that the inequality that we're going to work with, so I'm going to go ahead and highlight that in a pink, this actually does not come into play until we use sign analysis. So if you really want to, you can start off with the problem as an equation. Okay, maybe it looks a little bit more familiar. This is going to help you find your x values that you're going to kind of pinpoint on your number line, which will then help you with your sign analysis. So if we were to go ahead and factor this down, we would note x squared can be broken into x and x. Also note that both the middle term and the constant term are positive, which will tell me that I will have both additions happening in both of the binomials. Now we will go ahead and look at the constant term, and we have to figure out how best to split apart the 12. What factors should I use? In this case, I would suggest using 4 and 3. If you're a little bit hesitant to believe me, what I would suggest doing, and I strongly encourage you to do this anyway, is to pause the video and FOIL that out and see if you get back to the original problem that we were working with. So from here, we can use our zero product property, which states that if x plus 4 times x plus 3 equals 0, well then either number could potentially be equal to 0. We'll subtract from both sides to get x on its own. So we get x is equal to negative 4 and x is equal to negative 3. So from here, we will move to our number line. We'll go ahead and we'll label negative 4 and negative 3. And these get open circles because of the inequality that we're working with. We're working with a strictly less than sign. So that means that the values that we've indicated on our number line cannot be included as part of our solution. So the open circle almost acts like a bubble to keep it excluded. You can't reach in and use that. It's in its own little personal bubble kind of thing. From here, we will use sign analysis to help us figure out where our shading should take place. Okay, so we have 3 different areas to look at. We need to look at values to the left of negative 4, values between negative 4 and negative 3, and values to the right of 3. So basically those 3 sections that have been created by identifying negative 4 and negative 3. So for example, if we pick a value to the left of negative 4, say maybe negative 5, we'll go ahead and we'll plug this in, and we want to see if we're going to get a true statement out. So this would be 25 minus 35 plus 12 is less than 0. This gives us negative 10 plus 12 is less than 0, or 2 is less than 0. Well, that doesn't work, so we would not shade that section of the number line. So then, let's try values between negative 4 and negative 3. And odds are the best one to work with would be negative 3.5. Because that is a value that's in the dead center. Okay. So if we square negative 3.5, we would get $12 and 25 hundredths plus 7 times negative 3.5, which would give us a negative 24 and 5 tenths plus 12 is less than 0. If we combine those first 2 terms, we get negative 12 and 25 hundredths plus 12 is less than 0. And then if we finish off that addition there, we would get negative 25 hundredths is less than 0, which is a true statement, which means that I'm okay to shade in between negative 4 and negative 3. We can also check for values to the right of negative 3, and I would say I'm going to work with 0 because it's going to make my calculation and therefore my checking a lot quicker. My first 2 terms zero out, so then I'm left with the statement that 12 is less than 0, and that absolutely does not make sense. So that's why I'm not going to shade there. So my number line is correct, and then to reflect that in interval notation, I would say that I'm going to go from -4 to -3, and I use soft parentheses on either side because I'm working with an open circle. So let's go ahead and kind of carry this on into number 55. So for number 55, we're given x squared minus 5x plus 6 is this time greater than or equal to 0. And what I would like you guys to do is go ahead and take a moment to pause the video, and hopefully when you pause the video you have the example on the left-hand side to use as a reference. I want you to go ahead and try to solve this problem on your own, and then once you're done, resume the video and follow along with what I'm doing and check it against your work and your thought process. Make sure that your argument is as thorough as mine. Okay? Not that mine's the end-all and be-all, but at least you have I would say, a good reference to refer to. So from here, we would say we have x squared minus 5x plus 6, and I'm just going to look at the equality at this point, just to identify what values I need to make myself aware of on my number line. That will allow me to go ahead and factor, and this will become x minus 3 and x minus 2, which then allows me to use my zero product property to say x minus 3 could be 0, or x minus 2 could be 0, which then allows me to solve for x. So x could be 3, or x could be 2. So this allows me to move into my number line. And this time I can go ahead and, when I put circles on these, I'm going to close them because I have a less than or equal to. The equal part of that inequality allows me to close those circles. So now I move into sign analysis, and I need to pick a value to the left of 2. So I'm just going to kind of go in order. You don't have to pick segments in order. You can kind of test each segment however you wish. So in this case, I'm going to pick 0 because 0 is relatively quick to work with. The first two terms will 0 out, and I'm left with 6 is greater than or equal to 0, and that's true. So I can go ahead and shade that in. So now I can also check, and I want to pick a value that's between 2 and 3, so probably not too surprising. Oops, that square got a little funny, didn't it? I'm going to pick 2.5 in between. Okay, so if I do 2.5 squared, it's going to give me 6 25/100ths minus 5 times 2.5, which is going to give me 12 5/10. We take care of the first difference, then we get -6 25/100ths. And then if we take care of that addition, that's going to give me -25/100ths is greater than 0, but that doesn't make sense. So that's a false statement. I can't use that one, so I won't shade between the two. And finally, to the right of 3, I'm going to pick 4. It's going to give me 16 minus 20 plus 6 is greater than or equal to 0. -4 plus 6 is greater than or equal to 0, or 2 is greater than or equal to 0. And that's true, so we can go ahead and shade to the right of 3. So your interval notation will go from -infinity to 2. And this time we use a bracket because we had a closed circle. We're including the 2 as part of our answer. And we're going to have to union that because we have some dead space between 2 and 3. That's where all of your false statements or your lies or anything along those lines are going to be, so we want to avoid them. And then from there we go from 3 to positive infinity. Okay, so there is your solution there. Hopefully you were successful with that. If you have any questions, please feel free to come talk to me. I'd be more than happy to help you out.